Hello everyone, my name is Chen Junrui. I'm going to introduce the program half-wave rectifier and half-wave filter. My partner is Zhang Yuquan, and this is our outline. First, we introduce the AC to DC and the half-wave rectifier and filter, and we introduce equipment, oscilloscope. And second, we do the experiment. We do half-wave rectifier and filter. We have a simulation vs practice. And third, we have a result and discussion. And last, we have conclusion. First, let's introduce our topic. There are four steps in the AC to DC. The step down transformer, the rectifier, the filter, and the regulator. There are two purposes of step down transformer. We can protect the VRMS, and it is the left circuit by the step down transformer. And the second purpose is transfer the bigger voltage to the lower voltage. And the rectifier and the filter is today's our point. We can introduce this after this PowerPoint. And the last is regulator. The regulator can make the rock line like this to the flatter line. And let me introduce the half-wave rectifier. The diagram below illustrates the basic principle of half-wave rectifier. When a standard AC waveform is passed through a half-wave rectifier, only half of the AC waveform remains. Half-wave rectifier only allow one half cycle, positive or negative half cycle of the AC voltage through, and will block the other half cycle on the DC side, as seen below. You can see that if the diode is ideal, the VD equals to 0. But the diode with VD equals to 0.7, you can see it is lower than the ideal one. And the half-wave filter, you can see that during the conduction period, the capacitor charged to the maximum value of the supply voltage. When the voltage between the plates of the capacitor is equal to the supply voltage, the capacitor is said to be fully charged. When the negative half cycle is reached, the diode D gets reverse bias and stops allowing electric current through it. During this non-conduction period, the input voltage is less than that of the capacitor voltage, so the capacitor discharges all the stored charge through the low resistor IL. This prevents the output low voltage from falling to the 0. And you can see this is the ideal one. And if the VD is 0.7, and this curve will be lower than the ideal one. And this is the process of the charge and discharge. And let me introduce the equipment. Turn on the power and the gen out. Connect the digital BNC test load to the gen out, and the prop wave prop waveform and switch the sine wave with 10 VPP and 1 kHz as seen in the screen. First, we plug the oscilloscope, and second, we connect the BNC cable. Third, we connect the prop. The error often occurs with these two steps because we often do not fasten the cable. And the fourth is we can check the plug. If we can see a rectangular post in the screen, then this prop is available to use. And the fifth is convert frequency to 1 kHz. The sixth step is convert VPP to 10 VPP. And in the last Friday, we go into the lab and do the experiment. The upper left is the circuit diagram. The lower left is the actual circuit diagram. And the right is our result. And you can see VN is 5.4 and the Vout is 4.668. And we do the second experiment is half wave filter. The upper left is our circuit diagram and the lower left is our actual circuit diagram. And the right is our results. We see in the oscilloscope. We can see V in is 5.2 and the V out is 4.49. And you can see the charge and discharge. Also, we do the simulation. The upper is the rectifier. And you can compare to the experiment, yeah. And the lower is the filter, and you can also compare to the experiment. And you can see a changing state. The result and discussion. We find that in an experiment, the value of the peak of V in and the peak of the V out is higher than the simulation. We can see this is 5.4 and this is 5. And this is 4.68 and this is 4.32. But the difference between the V in and V out is almost the same. This also occurs in the filter. The experiment is higher than the simulation. The peak of V in is higher than the peak of V in and the peak of V out. The value of experiment is higher than the simulation, but the VD is almost the same, 0.71 and 0.72. VD as a constant voltage drop in the experiment approximately reached the same value in simulation. And our parameter we simulate is IS equals to 0.001 picoampere, and N is equals to 1.0675. If Is equals to 0.01 picoampere, Vd is 0.6 volt in simulation. We can see that smaller Is, bigger ID in experiment. And the final is the conclusion. I introduced the AC to DC for the transformer, rectifier, filter to the regulator. And today our point is focused on the rectifier and filter. The second is difference of waveform of output between half wave rectifier and filter. The third part is instruction of oscilloscope used to measure waveform. And we do the experiment to display the outcomes of circuit and simulation, comparing both of them. After the experiment, we do the result and discussion. Vd equals to 0.7 volts of rectifier and filter in experiment is the same as that in simulation. And this we find that different Is leads to different Vd. And this is our research and the reference. And this is our work assignment. Our presentation ends here. Thank you, everyone.